And welcome back. Joining us in studio this morning, as he does several times a month, our good friend from the OSU Extension Office in Wayne County, talking agriculture, Rory Lewandowski. Rory, first off, bid you a very good morning. Thanks for coming back in.
Thanks, Ron. Glad to be here.
Well, in our current climate of low milk prices with reduced or no payment incentives for milk quality, dairy farmers really are looking at milk components as a possible strategy to booster the milk check, if you will. In today's program, we're going to discuss at least some factors that affect milk component concentration. So to begin with, Rory, define exactly what we mean when we say milk components.
Sure. Well, in addition to water, milk is made up of three major components. That includes milk fat, sometimes commonly just called butter fat, protein, and then other solids, those three main components. The other solids component consists mainly of lactose and minerals. Dairy farmers then are paid based on the quantity of each of these components. So the milk check will list the price of each of these components. It's then multiplied by the pounds of each of those components that are supplied by the milk the farmer has shipped to the processor. Generally, milk fat and milk protein are higher price components, and lately, milk fat has actually been a larger contributor to the milk check than milk protein. For example, the USDA announced component prices for end of February of this year. For butterfat, were $2 and about 35 cents, kind of rounded up. For protein, the price was $1.65, and for the non-fat solids was about 53 cents, and then only about 5 cents or 5.5 cents for other solids. So again, bigger premiums, definitely looking at the fat and the protein components. But as you mentioned at the onset, with premiums for milk quality generally disappearing, one method that can generate some more income is to increase the percentage of each of these components in every hundredweight of milk that's shipped.
Rory, what are typical milk fat and milk protein percentages? You know, I'm familiar with walking into a store and buying whole milk or 2% or skim milk, but how does that relate to what the actual dairy cow is producing?
Yeah, good question. Well, those fluid milk categories that we see in stores are really more about marketing and consumer demand. Those categories are based on milk fat percentages, and they're manufactured from milk that's produced on the dairy farm. So whole milk is generally about 3.25% milk fat. 2%, of course, is 2%, and skim milk is then fat-free. Now, dairy cows, they produce milk that varies in both protein and fat content, but generally dairy producers are going to strive for herd averages of typically about 3.5% for butterfat and 3.1% of protein.
Rory, since we're talking about changing milk component percentage, that means that obviously they are not static or set at some predetermined percentage in each cow. So let's discuss some of the factors that can change milk fat and milk protein. How does the breed of cow, or does the breed of cow, affect the percentage of fat and protein in milk?
Yeah, well, breed is actually a significant factor. So in general terms, Holsteins have the lowest fat and protein percentages, while the Guernsey and in particular Jersey breeds have the highest fat and protein percentages. Now, on our Wayne Ashland Dairy Service Unit board, we have some unabashedly vocal Jersey supporters as well as some Holstein breed supporters. And there's a lot of good-natured teasing that takes place between those two groups. Now, the Jersey camp thinks it just makes sense to milk Jerseys, given that they're naturally higher component percentages. But then the Holstein camp typically counters with the fact that, well, Holsteins produce more total milk or volume, and that higher volume multiplied by even a lower fat and protein percentages results in a higher total yield of fat and protein. So you've kind of got both sides there. However, I would say in our current milk market situation where we have a oversurplus of fluid milk and really processors are not looking for more pounds of milk, that I have heard of more Holstein herds considering maybe the addition of some Jerseys to try to booster those milk components.
Once again, our guest in studio today from the OSU Extension Office, Rory Lewandowski. Rory, in addition to breed, I imagine that nutrition must play an important role. So how does milk fat and milk protein become then a part of milk?
Yeah, that's a good question because we really have to understand the source of milk fat and milk protein and how they are formed to be able to understand how nutrition might be used to bring about changes. So let's start with milk fat first. Within the rumen of the cow, products of digestion by the microbes in that rumen include volatile fatty acids. They're commonly designated as VFAs. Now, those VFAs typically are acetate, propionate, and butyrate. The proportion of each is dependent upon the feedstuff that's supplied to the rumen microbes. So concentrates, think grains here, they yield a high propionate percentage, and propionate is used to manufacture glucose that's used to produce milk volume. Digestion of high fiber feeds, so think our forages, yields a higher percentage of acetate and butyrate. Now, those two volatile fatty acids, and in particular acetate, are used in the udder of the cow to form about 50% of the fat that's available in milk. So the diet is highly correlated with milk fat concentration or percentages. Changes in the diet can directly impact milk fat percentage. For example, diet change could alter milk fat percentage as much as 1 percentage point within a fairly short period of time, within 7 to 14 days.
We're talking again with Rory Lewandowski about factors affecting milk components. And Rory, how is milk protein formed? Does diet affect milk protein as directly as it affects milk fat? For example, can milk protein percentage be increased by increasing the protein content of the cow's diet?
Right. I mean, that would seem to make some sense just thinking through it. But milk protein actually contains several different types of proteins, but primarily they're grouped as caseins and whey. So each protein then has a characteristic amino acid composition. Milk protein is synthesized from amino acids in the blood that come from those rumen microbes as a result of, again, the rumen digested diet protein. That microbial protein provides about 50 to 75% of the amino acids in the blood. However, because the cow is also using amino acids for other body tissue functions, it's really a little more difficult to manipulate directly milk protein by nutrition. In fact, in the late 1970s, Dr. Roy Emery from Michigan State University established the fact that the protein content of milk increases only about 0.02, or about 0.02% for each 1% increase in dietary protein within recommended limits. So total milk protein concentration is rarely altered by more than maybe 0.1 to 0.4 of a percentage point due to the diet. And those changes are slower in response. They can take up to 3 to 6 weeks to occur. So one commonly held model regarding milk protein and nutrition is that milk protein production is usually limited by the amino acid that is in the shortest supply in relation to requirement. And typically, lysine and methionine are recognized as the two most limiting amino acids to milk protein production. However, at the 2017 Tri-State Dairy Nutrition Conference, a paper presented by Dr. Louis Armentano, a professor emeritus at the University of Wisconsin-Madison, suggested that milk protein formation is actually much more complicated. In fact, it may involve interactions, possible antagonism between different amino acid compositions, all those factors provided by the diet, and also is influenced by the diet energy supply, the supply of insulin, and cellular control proteins. So, in addition, some studies suggest that histidine, another amino acid, may also, either by itself or in combination with lysine and methionine, affect milk protein concentration. So, short answer is milk protein formation is a little more complicated, and we can't affect it as directly with the diet.
Well, Rory, we need to wrap up our program for today, but we're going to continue this discussion along with some practical management practices to help improve milk components in next week's show. So stay tuned for that. In the meantime, if somebody has questions about anything that we discussed today, and we covered quite a bit, what do they need to do?
Yeah, they can contact me at the Wayne County Extension Office at 330-264-8722, and I'd be glad to provide them with some of the documents and articles that I'm referencing for this information presented today.
Rory, as always, appreciate the time.
Thank you, Ron.
Once again, our guest in studio, Rory Lewandowski from the OSU Extension Office, talking, as always, agriculture. Stay tuned. More on the way after this.